Find the dimensions of a rectangle whose area is 8,000 and whose perimeter is as small as possible. So there's a lot of ways to make a triangle with an area of 8,000. You could have a rectangle that's 1 by 8,000, or one that's, I'm trying to come up with believable measurements here. It could be 40 by 200, or it could be 28.3 by 28.3. And there's an infinite number of other combinations that will give you 8,000 for your area. One of these uses the least line, has the lowest possible perimeter. So let's see if we can find which one it is doing our derivative thing. We're trying to minimize perimeter, and a rectangle's perimeter is 2L plus 2W, or 2A plus 2B, or whatever you like. And the other thing we know about this rectangle, I'm not sure what its shape is that its area is 8,000, which means length times width equals 8,000. Now, if we're trying to optimize the perimeter, the standard thing to do would be differentiate it, but we get this problem that we see so often where we have two variables and we don't like that. So, can we get rid of one of the variables? You betcha, we have this other formula that will enable us to do that. We can say here that if we divide both sides of this by L, you could divide by W if you wanted, I've chosen L. We get W equals 8,000 divided by L. This means up in the perimeter, right here, where we have W, we can write 8,000 over L instead. And so we get the perimeter of this rectangle is 2L plus 2 times 8,000 over L. And we can clean that up a little bit and get 2L plus 16,000 L to the minus 1. This is better. Now we've got an expression for perimeter, and it's only got one variable in it. So we can differentiate this, and it shouldn't be too much of a headache. Let's see what we get when we do this. dpdl is, the derivative of 2L is just 2. And then we get minus 16,000 L to the minus 2. And you remember, if we're doing an optimization, we want this derivative to equal 0. That'll tell us where we're at the top of a hill or the bottom of a valley. So can we solve this thing? 2 minus 16,000 over L squared equals 0. How do we get out of that? My preferred attack is to multiply everything by L squared, because denominators, I like it when denominators go away. So if we multiply by L squared, we get 2L squared minus 16,000 equals 0. Take the 16,000 to the right, we get 2L squared equals 16,000. Divide by 2, L squared equals 8,000. And from that we get L is the square root of 8,000, which is 28.3. And if you calculate W based on that, it turns out W is also the square root of 8,000. So it's also 28.3. So the most efficient rectangle as far as saving on perimeter is actually a square. 28.3 by 28.3. And in general, you're going to find that circles and squares and shapes like that that are balanced, they're not really long in one direction and smaller in the other direction. Those tend to be optimal shapes, and they tend to use the minimum amount of material to cover a certain amount of area or a certain amount of volume. I'm sure we'll see that in other examples coming up.